Hello everyone. I chose this word problem because I've actually been doing a lot of wrapping for Christmas. And every time I wrapped a gift, I thought about this word problem because instead of cutting out the corners, I am folding them so that my gifts are perfectly wrapped. Shout out to this word problem for helping me figure out my math with that. Anyways, on to the word problem. So, a candy box is made from a piece of cardboard that measures 13 by 8 inches. Squares of equal size will be cut out of each corner. The sides will then be folded to form a rectangular box. What size square should be cut from each corner to obtain maximum volume? Those were a bunch of words. So let's go ahead and give ourselves some visuals to work with. Let's go ahead and create that box. I'm going to go ahead and put this box on the corner or two just to show the corners that we're going to cut out. And since we don't know how big of the square is going to be that we're cutting out, we're going to put an X there. And then for the length, it's going to be 13 by 8 is going to be the width. Since we have everything set up, it's important to think about how to find volume. The formula for volume is usually going to be length times width times height. Now, our length isn't simply 13 because we're going to cut out those corners. So when we write out our volume formula, we're going to think about that. And the same aspect applies to 8. Now that we've written out how to find the volume, we now have to try and figure out what L is, what the width is, and what the height is. Since we don't know the height of the box, it's going to simply be the X because that's what we're trying to solve for right now. Length is going to be 13 minus 2x because there's 2 corners that need to be cut off from the length, and that same concept needs to be applied to the width, right? So it's going to be 8 minus 2x. Now that we've got that all figured out, we're going to plug it in to the volume formula that we have. Volume is going to equal x times the length, which is going to be 13 minus 2x, times the width, which is 8 minus 2x. We're going to multiply the x throughout, and we're going to simplify it. Now that we have our formula, we're going to find the derivative of it, and we're going to get 104 minus 84x plus 12x squared. And then we need to factor that out so that we can find x pretty much. Unfortunately, this isn't one of those pretty problems where it factors out nicely. We have to use the quadratic formula. And that's going to be x equals 21 plus or minus the square root of 21 squared minus 4 times 3 times 26 over 6. And now we're going to go ahead and try to figure out which x it's more likely going to be. So the first one's going to be x equals 12 plus 11.36 over 6. And that's going to equal 5.4. And when we solve for the next one, it's going to equal 1.6. Now, what we're trying to do is figure out which one it is. Can it be 5.4? No, because 5 is practically more than half of 8 inches, and same with 13. So it's way too big to be something that can abstain maximum volume. So we're going to go ahead and stick with a 1.6, and that's going to be our answer. Thank you for listening.